Hi everyone. Let us just make sure that we are live on Facebook and then we can start.
Good luck. You don't need it actually. So good luck to Portugal only in a few hours, but you don't need that. Comes live. Okay. So welcome to the demo day of batch 566. A batch not only from Wagon but also from Nova SPE. My name is Nuno. I'm the driver for Wagon in Portugal, so the general manager for the company here. And I just want to have an intro to explain a bit on what is Wagon and what were the 6 months for the 9 students we have here today. So basically we are a coding school. On our inception, the key concept has always been to bring technical skills to non-technical people. In the beginning, teaching them how to build web applications, but since last year also teaching them about data analytics and data science. And our students after the bootcamp do different things. Some of them have a new toolkit to use on their jobs, some change careers, and others start their own business. And as I said, we have web development, data science, and we have full-time and part-time formats. In the specific case of batch 566, it is a part-time data science batch. They've started in January, so several months ago. It has been a huge commitment because these 9 students have been having classes with us every Tuesday and Thursday in the evening, and also every Saturday for 6 months. So no beach on Saturdays during 6 months in Portugal, as you know, is a lot. And they've started by the basics of coding with Python and how to do data analysis with Python, with Pandas, with NumPy, how to do data-driven decision-making, how to build the first machine learning models with scikit-learn, how to implement deep learning models with Keras, and then a lot of different softwares and tools to deploy these models into production, like Docker, Heroku, Streamlit for the front end, FastAPI, etc. So a lot of information for 6 months, only mainly if you are working full time and have a family to take care of, and so on. So about the projects today, we have 3 really cool projects by these 9 students. What you'll see today is the work of 1 month only, so it's not the work of 6 months, just the final month where the students in teams have built the project with real data. And to put that into perspective, what you'll see in terms of full-time hours, it's just represents 7 working days. So what you'll see is just 7 working days, and I want to repeat that because you'll see where they got and the value of what they built in that short period of time. And obviously, because these are data science projects, the most important part is what you don't see. So the apps that you see with Streamlit, it's basically 1 lesson of the bootcamp, and it's like just the final part of the projects, but everything that comes under the hood of the predictive models that the students will present to you is actually where the most valuable part of their learning experience is at. So without taking much longer, I will hand over to João. We'll present the groups, and wishing good luck to all of you.
So, hello everyone. So for our first group, we have the group named Hold I Am with Tiago from Portugal and Felix from Germany. So whenever you can, share your screen. Good luck.
Okay, now I think it's working. You should see the presentation. So thank you for the nice introduction. My name is Felix. Me and my colleague Tiago, we are presenting how old I am, age recognition. So imagine you're at a party and you see someone, a girl or boy, and you want to know how old is she or is he. Now you can just take a smartphone, make a picture, and the algorithm will say you how old this person is. So, but first of all, if you just download an app in the App Store, the Google Play Store, there are apps for this, but you will see these apps are not really so good. And the problem is that they try to predict the real exact age. And the problem is humans and neural networks, who are basically working like a human brain, are not so good in guessing exactly the right age. For example, if you would see these two persons, maybe you're familiar with them from Friends, it's Matthew Perry and Jennifer Aniston. If you guess now how old they are, maybe take a second. Maybe you have two numbers in mind now, and they are both 51. And would you guess this? I think not. You would think, okay, Matthew Perry here, he doesn't look so good in this photo. He's maybe older, maybe like 60. And maybe Jennifer Aniston is a woman who takes care of herself, especially in this picture. She's maybe between 40 and 50 something. And the thing is, the guessing the age is really difficult, but guessing like age buckets is simpler. This is what we do because we think humans are good in guessing age buckets. If you see these two, you would see, okay, they are both maybe between 45 and 55. This could be, yes. This is what we're doing. So this is a classification problem. You don't get a number, you get like a bucket. And yeah, we would like directly in the beginning show to you this app. So if you have a smartphone, you can just have this QR code, but we show this QR code later. We now go directly to the app. And why not do this app directly with our two pictures that we've shown you? So you just click on here, post files. On the smartphone, you can take a picture if you want. So we go on Matthew Perry. First, you see it uploads the picture, and then you can here push the button to predict the age. It will take a while, and you see here what we're doing. First, we crop and resize the image. So we only predict on the face. And this picture is what we're predicting. And after a few seconds, see here in the top that's running, it will give you the age when the balloons are there. You see, the age is between 51 and 65. This is what we are guessing. We think also you look like 60. But the important thing is here, like this age bucket. And here's actually 51, so it's in this age bucket. We think maybe, yeah, a little bit older, but in this age bucket, so it's white. So now we do Jennifer Aniston. It's uploaded, you predict the age. The second time you do it, the algorithm is faster because the model is already loaded. You will see it, and here the age is between 46 and 60. Here we are directly guessing the right age, but there's a little bit like luck. But this is like, okay, she's 51. You think, okay, she's between 46 and 60. It's quite wide, even maybe a little bit less than 51. So how we do this? So first we use a data set.
So for the data set to train our model, we are using the UTK face data set, which contains over 20,000 images going from 0 to 116. And we have information regarding their age, gender, and ethnicity. Can you skip, Felix? I don't. Yeah, okay, regarding the pre-processing of the images, in order to train the model, we just had to remove some. You can see that not all the images are faces, and a few of them are blurry as well, or are wrongfully tagged. For instance, the one in the middle with the the black man, he was tagged as being 3 years old. So we just removed these. We also, to make it more simpler to train the models, we also resize the images, so to be a bit smaller, and we are not losing any quality of the image. And we even comparing the data set, which has ages from 0 to 116, we are only using from 1 to 80. And as Felix said, we are better in using age buckets. So we have 16 age bins of 5, so 1 to 5, 5 to 10, etc.
So which model did we choose? We first tried a PCA, a principal component analysis, but this didn't give us the result we wanted. Then we tried a neural network. For images, you normally start with a convolutional neural network. This is like state of the art. And we used like convolutional layers. We used 5 times of it. Here you see the complete code. We did some max pooling and some dropout. Dropout means that after doing these layers, we delete some information. This is good doing because you have like overfitting problems that you here have a lot. In the end, we have flattened the layer. You see it here after a few convolutional layers, we had 5, you have a flattened layer, so 1 vector. And then after another dense layer of, you see it here, 100 neurons and another dropout, we went to our final dense layers. And this had 60 neurons, so exactly as much as H bins that we have.
So we also wanted to see how our model compares to other models on the web and from papers by other engineers. We only found a couple from two other groups. They are using similar models up to some point, but the data set is different. So they have only 8 bins, which is much smaller, and they are non-continuous age bins. And not to mention that the age range, it's way smaller. So although they do have better accuracy and although they have better metrics than we do, you could say that their data is easier to work on and it ends up being less accurate. Just to give a perception of the metrics that these models use, we have the accuracy, which is the ability to predict the accurate bin. And the one-off accuracy, it's basically, we predict on, in this case, the 36 to 40 bin, and we expand it, which is also what we are showing on the website. So in order to have a higher percentage, a higher hit rate, let's call it.
So if you go to the app again, and let's see what the app does with pictures that are clearly not humans. Maybe we can guess the age of the cat as well. Let's see. But first we try a few other pictures. First, 2 pictures of the same person is quite interesting. We try Antonio Gusta, the Premier Minister of Portugal. The uploaded picture predict the age. He is I forgot the age. He's 59. Oh, it's 59.
Yeah, he's 59.
Yeah. So here, first picture is like between 51 and 65. So perfect. We think he looked like 59, so it's like perfect. But if he has, of course, a little bit different face or maybe other makeup or another mood of the day, you could say, okay, he looks a little bit different. He looks a little bit younger. And of course, then our apps will guess, okay, he looks here a little bit younger. We can only like guess what the image is showing to us. And here we're guessing he's between 46 and 60. So we are not guessing here the right age, but we are right in this age bucket. And this is what is pretty important. So just for having a little bit fun, we have 2 pictures of 2 teammates of us. You will see them later in the presentation. Rodrigo, let's see how old he is. You can maybe guess how old you think he is on the picture. I will say it to you. So it's between 21 and 35. In this picture, we think he looks like 30. I hope it's right, Rodrigo. You can say it later. And Vera, I have a picture of you too. Yeah, let's see how old you are, depending to our algorithm. So here we think you're aged between 21 and 35. I hope it's right. No offense. And on the last, yeah, now the cat. Let's see what he does with the cat. Yeah, he say there is no human face in the picture, so we cannot predict the age. So he detects if he actually find a picture, if you find a human face. Actually, if you find a human nose on the picture, then we can like predict the age. So
moving forward and to continue with the work, of course, it's always good to have more training data. In this case, the data set that we use, most of the data is compromised between the 20 and 40. As I said at the beginning, we also have information for ethnicity or for race, and which is also a possible target instead of age. And yeah, our initial idea regarding the inputs of the website, we wanted to try also to snap a picture from the camera instead of uploading one, and even video streaming. So sort of having a box around your face, and as you move, it tells you the age. But for next time, if we continue this work, when we continue this work, it will also be a possibility.
So yeah, then thing that we can say to you, visit our app now. You have here the QR code. You can directly try it out with the smartphone, make a selfie of you and see if the app is right. Like saying nearly 80% is right. So not always, but most of the time. So thank you.
Nice job, everyone. So really cool. So maybe a cool question would be if you can predict the age of an alien, that would be cool. So maybe if you have someone that could help us out with that. So our next project will be, it's called Meet an Alien. It's a project from Vera from Portugal, Juan from Spain, and Josep from Spain also. That can help us out to check at least where another possible alien would appear or another UFO would appear. So with that said, you can start, guys.
So, hi everyone, good afternoon. Thank you for coming. Our project is called Meet an Alien, and our goal is to help you find an alien. The team here is composed of myself, Vera, a Star Wars geek, Jose, a security expert, Juan, a UFO enthusiast. And we wanted to know if the aliens are real. There's evidences of them all over the internet, and the CIA has even released a couple of videos of weird objects flying around in the atmosphere, and they don't know what it is. They suspect an alien. And we want to use AI to help us understand and predict if there are going to be any alien sightings, when and where. So we want to tell you where to go and when to visit the aliens and perhaps, talk to them. We'll see. Take a picture maybe. And so the data sources we've used are the National UFO Reporting Center. There's a website that collects reports all over the world of alien sightings. We found a Kaggle data set that has been cleaned up before, and it has sightings from 1949 till 1999. And then we also scraped ourselves some data from this website, the National UFO Reporting Center, and we scraped it from 1999 to today. So it's up to date. We noticed that most of the sightings reported were coming from the USA, and so we concentrated on predicting inside the USA. So I'm sorry that for now we'll not be able to let you know where other sightings are happening anywhere else in the world, but if you go to the US, we'll sure be able to let you know. During our data exploration phase, we noticed that more people reported from 97 onwards. So we did specifically looked into that historical data to be able to predict into the future. We noticed that aliens happen to be sighted more during the summer and then in the winter. Maybe they don't like the cold. And we also noticed that aliens don't care if it's weekend or if it's a weekday, so they will show up no matter what. In the picture here, you can see in green the areas where sightings happened, and the red dots are the different our population sizes. So the bigger the diameter in the circles, the bigger the population size. From this, we inferred that population size and alien sightings go hand in hand. Mainly, we suspect that the more people there are in a place, the more people there are to actually report the sightings. And if there's no one, then there's no one to report the sighting, even if the alien goes there. So we know now, we use the population size as one of the major features to understand if there will be or not a sighting in the future. So our model is composed of three main features. We aggregated location by state because, well, US is very, very big. We aggregated time by seasons, so it's a little bit easier to predict as well, so 4 seasons. We looked at population for each state, season, and year. And we also used secondary features like the type and the shape of the ship that people saw. So our model will be predicting how many sightings we expect to happen for the next season for a given state. And now Juan is going to introduce to you a little bit more of details on our model.
Yeah, so one of our main hypotheses was that aliens are indeed coming to visit us. They're not doing so in a random manner, but that the sightings have a schedule, so to speak. You know, we assume they are organized people, and they have a strict schedule, and they come in specific moments of the year or specific dates. So we thought that a linear regression model would be better at finding this pattern in the data, this schedule that would remain constant throughout time. And so we decided to use a gradient boosting regressor because especially when fine-tuned properly, it does give you very good precision. And after training our model, we've got a mean absolute error of 1.23. So that means more or less that we can predict the number of sightings plus or minus 1.23 sightings per season. So for example, if we predicted that a season would have 5 sightings, the actual, on average, the actual number would be either 6 or 4 sightings. So we think it's pretty close to the real outcome. And we've prepared a nice little dashboard where all you UFO enthusiasts can come and kind of run these predictions in case you want to get out and have your cameras ready, so we can start taking nice videos and pictures, and we can stop having those blurry images that don't let us confirm for sure that UFOs do exist. So Vera, if you... Okay, so we've created this dashboard where we have an updated map of the latest reports in the US. We wanted to have this here so that so that other UFO enthusiasts can have an idea of the scope of this project, that you're not the only one. There's many of us out there trying to catch these guys. And then on the left, we have a little input bar where you can select the state that you want to go UFO hunting, and it'll tell you more or less the number of sightings that you can expect in the next season. So right now we're predicting for this summer, given that we're still in spring. So this summer, this next couple of months, in Virginia, for example, you can expect to have 17 sightings. So that's a lot of chances of catching them in image. Here we have also added this graph so you can get a better idea of the performance of this model. This is showing the previous season versus the actual. So our model predicted that during the spring there would be 14 sightings, when in reality there were 13 sightings, I think. So as you can see, it's pretty close to the actual. And I mean, right now it's pretty broad, you know. So I mean, 17 sightings spread out in 3 months. You would really have to go out every day to try to catch them. So for our next steps to improve this project would be to be a bit more specific with predicted by month, or I mean, it would be amazing if we could predict it by the specific date. And then also we would like to add in the dashboard a reporting tool in which when you go out and see an alien, you can come right in and give us a report, or where you saw it, when you saw it, what you saw, maybe even send in an image, and we can send it to Felix and Tiago and have them age the alien. Who knows? But yeah, this is what we came up with, and thank you for listening.
Guys, really nice job. It seems like it was a really fun project to work with. So nice. So our final presentation. So for last but not least, if we want aliens to visit us, maybe we need to take a little bit better care of our planet, right? So for that, maybe we should invest more in renewable energies. And for our last group, we have Predicting a Renewable World with Rodrigo from Portugal, Michael from Germany, and Haku from Germany as well. So the floor is yours, guys.
Thank you. You are absolutely right, Joao. We should definitely speed up the investment and construction of more renewable sites. So yeah, we chose a task in a big challenge, has been called the biggest challenge humanity ever has faced, to get to a 100% renewable world. And the biggest part there is to transform the energy grid. And Michael, our brain and designer, Rodrigo, our code wizard, and myself tackled this task with a predictive model. But first, what is really the problem here? So when you want to get to a 100% renewable energy grid, the volatility of the energy generation is a problem. So when you want to use energy, it needs to be simultaneously matched in the grid. So when you want to use a light bulb, there needs to be generation on the other side. And right now, solar and wind are the only technologies that are scalable and renewable. And the wind doesn't always blow, the sun doesn't always shine, and that's a problem. And we think we can make a big dent here in making this more transparent and more predictable when you can expect how much energy at what time frame. And just to set the stage a little, even though governments are now setting big targets to hit that, the action has been missing. And one case in point is the expansion of wind energy in Germany, which is the market we're looking at for this project. In 2017 was 5.3 gigawatts. But in 2 years, it dropped to less than 1 gigawatt new expansion, which is mainly a problem of bureaucracy and being certain when you can see a return on your investment when building such a structure. So what stands in the way is capital costs and being certain that you do not make a loss on this when you implement this. And for that, to bring some kind of predictable and transparency into the world, we build a big model. So we looked at the weather data to give us the prediction, and Germany does provide very detailed, very broad data in that sense. So we have more than 500 weather stations which report hourly on all kinds of parameters. And we looked for our wind model on the one side. We looked at wind speed mainly, but also air pressure, humidity, and temperature. And on the solar side, we looked at global radiation, which is a combined parameter of direct sunlight and indirect sunlight. So we get all the data we can find there. And our process of finding the final model that gave us the best value in our little trip, I will hand off to my colleague, Rodrigo. Please follow.
Thank you, Hawker. Hello, everyone. I'll explain a little how we came up with our model and talk a little about the process. So first, our first approach was using a time series. Time series takes into account the time evolution of the wind energy that was generated to predict on future values. And we used it to make a baseline to understand how far were we from our predictions. But we weren't really getting good results, even with the recurrent neural networks and Facebook profit. As you can see by the plots we have here, the blue line tries to predict the red line, which are the real values, and we just had like a flat line that didn't really get the variations we were expecting. So then we tried a new approach with a more traditional machine learning model, which doesn't take into account the time evolution of the training data, just to test the hypothesis that the future energy production could not be related with the past production values. But this also didn't yield good results. So we turned into the time series again, where we found the best model. And the key aspect for getting these best models was selecting the right features and the right time window on which to train the model. So here we can see the first models we had were really not picking up any changes on the predictions, but then after selecting carefully the features and the time window where to fit the model, we got a very close prediction. And so for our best models, the final models, we have a wind model that's a time series model, namely the Sarek Max model. As features, we used wind speed, humidity, air pressure, and temperature averaged around all Germany. The model was trained on the past 6 month data, and the mean percentage error was around 30%, which is well within the grid management capacity, which is really important. So companies can manage these differences. Our solar model is also a Ceremax model, and as features, we use the global sun radiation of the most significant weather stations in Germany. So this model was fitted or trained with 1.5 years data, and the mean percentage error was around 6%, which is even better. So now I'll pass to Hawk again, who will make a brief demonstration of our final product.
Exactly. So having built this model and having a good predictive value, we put this into a product that I'm showing you right now, and where everybody can access under this link. So where you can put in a future time frame, in this case 5 days in advance, because that's the time frame weather predictions give us this specific values to feed into the model. And when selecting, you can either choose if I want to have wind or solar or both. And it takes a while to load. So we get a little fun GIF to pass the time, but you can do also the same thing with future generation from, where is it? From solar, providing the same time frame. And right about the second, it will give you a prediction by hourly step, which is really important and very helpful for specifically good transmission companies. So that you get it really detailed on how much at what time of the day, how you can expect this much, because they need to match this simultaneously with the energy demand that is in Germany right now. The red line here is just to show you like a comparative value. This is the last year's production on the same day. And as you can see, from tomorrow on, you can expect a lot of energy coming in from wind. And when you can shut off coal plants, what should be part of the final solution to shut more and more coal plants off. And same thing in the solar model with an obvious pattern here, because at night there's no solar generation. And actually this last year's day and today is pretty much the same, or like tomorrow. And every 24 hours, there's another prediction like this. Okay, to sum up what we have learned by diving deep into this kinds of problem is that a machine learning model like this is definitely a good solution to managing the volatility. Specifically in the solar energy production, you can have a real accurate prediction of how much you can expect and plan accordingly. It is a little harder to get the right to get an accurate model for wind, but we do expect that there's data we do not have yet. So we expect a grid transmission company who gets to distribute it, has some kind of priorities we are not aware of, because sometimes the highest peaks in the production and the lowest valleys did not match the wind data. So I think we're missing some domain knowledge here. But with more time, money, and this missing domain knowledge, we can even make this more predictable, more accurate, and this could have a real impact on managing this volatility in the market, and the the transformation of the grid should not be held back by volatility only. And yeah, finally, with great teachers and inspiring colleagues, you can achieve a lot with important issues in a short time frame. What is to come for a project that wants to predict the renewable world? We think there's still some gains to be made, specifically with a stacked model where we can implement more data like we suspect regional companies and domain companies who really work in this will have, which are though not public knowledge. And combining this with a regional model where you can predict by postal code how much solar energy you can expect in your backyard for your solar panel, or a regional government who plans a new wind turbine can calculate how much energy megawatt hours they feed into the grid, and can easily calculate the return on invest here to bring more transparency to the market and to the big task we are all facing. Yeah, so we are very hopeful that this will be solved by data, partly by data. Thank you for your time, and yeah, let's make it happen.
Hey everyone, thank you very much for your presentations. Thank you also for your effort during these 6 months that flew by, I guess. Some of you were working while doing this bootcamp, so you deserve even another round of applause. But yeah, I don't know, Nuno, do you have anything to add?
Yeah, just want to congratulate you guys. It's amazing the projects you did and how well you clearly understood what you were doing. And it's something that I already told yesterday in the demo day for the full-time batch, which is like teachers always come to me and say, like students are so good nowadays, they are so much better than you were. And I'm half offended, half proud. And you can clearly see in your projects and in the way that you explain them that you did really well, and the feedback from all teachers has always been amazing about you. And another thing that is really cool to see is that like the three projects were like really interesting in the way that, for example, you are like trying to predict UFOs, you are like predicting like energy consumption and so on. Like my project with Philip was also was a teacher with you guys, was just about like recommending the next meal. So just like food. So it was, you can see that your batch was much more focused in the future of humanity and the universe than mine. We just cared about the dinner. But yeah, so really great projects. I wanted obviously to thank you all and for working so hard and always pushing through. But also Nova that partners with us for the part-time bootcamp, so Lenny and the team, and obviously the teachers in no particular order. So Margarida is down in the corner of my screen, so thank you a lot. Eduardo and Shiwei also work at Nova. Thank you a lot for your support. And I think Shiwei did, I don't know, it did like a couple of months of teaching with you guys. Sud, Tiago, Jose as well, and Philip, who I already mentioned, and also obviously thanking João Viana, not only for the teaching, but for the bootcamp management as well. So thank you all for your effort every day. And thank you all for watching the demo day. And you know, batch 566 has arrived to its destination. So yeah, oh, Shiwa is here. And yeah, thank you a lot for taking part of this journey, and I'm looking forward to see what you do next. So congratulations.
Congratulations, guys.
Thank you, guys.
Thank you, guys.
Yay.